My name is Matt Douthwaite. I'm from the Centre for Bio-Inspired Technology at Imperial College London, and I'm here to talk about my work on an NFC-based batteryless CMOS ISFET array for real-time measurement of pH in biofluids. So the application we're working on is for wearable chemical sensing. And this is important for basically taking real-time, non-invasive measurements of physiology for sports science and healthcare. Normally when you take kind of chemical measurements of physiology, you take blood tests, which are invasive, not very comfortable, and also you can't take them continuously. So we aim to use other biofluids, such as sweat, to take measurements of the physiology of the body in real time and more easily accessible. The challenge we're aiming to tackle with this demonstration is how to power such devices. Batteries introduce unwanted cost and unwanted size, so it's better to come up with an alternative solution, especially if your sensing devices need to be low cost and disposable, because the lifetime of chemical sensors is quite short. So the innovation that we've gone for here is developing a very low power CMOS microchip containing chemical sensors, which are ion sensitive transistors known as ISFETs. These sensors are part of the microchip and all fully integrated in the device, and the whole chip consumes less than 10 microwatts. As a result, we're able to power the device through energy harvesting sources, and in this case we're demonstrating wireless powering through NFC. So the demonstration is a kind of benchtop setup of the idea, the principle. So we have our chemically sensitive ASIC on the top here, underneath a flow cell, which allows us to place pH solution onto the sensing surface to represent sweat. As you exercise and you begin to sweat and become dehydrated, the pH of your sweat changes. So sensing pH is a nice introduction to looking at the properties of sweat on the body. So the ASIC is housed on a development platform purely for testing purposes, and it is connected to a commercial NFC harvesting board from Silicon Craft. Now, the harvesting board contains a coil, which allows us to harvest energy from a standard smartphone, which uses an NFC principle, which is the same method as contactless payments, and it's in a lot of many smartphones. So the phone provides power. It's regulated down to a stable 1.2 supply for the microchip, and the microchip detects the pH, and on board converts it into a frequency. So we have a pH to frequency converter on the microcontroller. And this allows us to get a nice, simple analog to digital conversion for detection. The phone also provides enough power to power a microcontroller, which then measures the frequency for us, and for the purposes of this demonstration, displays it on a LCD screen. But in future, it could be expanded to show on an app. So for the demonstration, I'm currently have a pH solution of pH 7 applied, and then I will apply a lower pH to the surface of the chip using this flow cell. And we'll see a change on the LCD screen. We'll see a change in frequency. So ultimately, the next step for this work would be to bring this into a flexible patch, which can be worn on the body. We then have you can then imagine a modality where somebody is exercising or being generally monitored, and you can tap your phone to this patch and get an instantaneous analysis of pH, or in future other metabolites, ions or metabolites such as sodium, potassium, perhaps glucose and lactate if the sensors were expanded. But there's also the modality of a wearable smartphone holder, which people often wear on their wrists to power a patch continuously and get continuous and real-time information of physiology as somebody exercises. Thank you.